How do mechanical engineers design efficient heat exchangers? Have you ever wondered how mechanical engineers create heat exchangers that work effectively and efficiently? Let's break down the process step by step to understand how they achieve this. First, engineers start by defining what the heat exchanger needs to do. They consider the purpose, the heat transfer rate required, and the operating temperatures and pressures. They also look at the properties of the fluids involved. This initial step is essential to ensure the design meets specific needs. Next, they choose the right type of heat exchanger for the job. Common options include Chelan tube, plate, or tubular designs. Chelan tube heat exchangers are popular in industrial cooling systems because they are strong and versatile. During the thermal design phase, engineers calculate the heat duty, which is the amount of heat that needs to be transferred between the fluids. They use the temperature difference between the hot and cold streams, fluid flow rates, and properties like density and thermal conductivity. These calculations help determine how much surface area is needed for heat transfer and how efficient the exchanger will be. After that, they decide on the tube layout, the number of tube passes, and the diameter and length of the tubes. This is done to maximize heat transfer while keeping pressure drops low. Engineers also take fouling resistance into account, which is the buildup of deposits that can reduce heat transfer efficiency over time. The mechanical design phase ensures that the heat exchanger can handle the stresses it will face during operation. This includes selecting materials that can withstand pressure and thermal expansion. Engineers design the shell diameter and thickness, tube sheets, baffles, and expansion joints. They follow industry standards from organizations like the Tubular Exchanger Manufacturers Association to guide their choices. Throughout the design process, engineers often go back and forth between thermal and mechanical design steps. This helps them find the right balance between heat transfer performance, durability, and cost. Before the final design is approved, it is validated through calculations and sometimes simulations. In practical applications, this design approach is crucial in cooling systems found in power plants, chemical processing, and heating, ventilation, and air conditioning systems. By carefully analyzing fluid properties and operating conditions, mechanical engineers create heat exchangers that optimize energy use and ensure reliable operation over time.